Okay, so in this lesson, we're going to look at simplifying complex fractions, and we're going to look at methods 1 and method 2. And in number 1, we have this complex fraction. So we have fraction divided by fraction. And notice that in the numerator, you have, if you want to think about it, you can rewrite this as 5 divided by 1 minus 10 divided by x. So in the numerator, you have two fractions. And the same thing in the denominator. I can write this as 1 divided by 1 minus 4 divided by x squared. And it does not matter which method you use. In this case, using method 2 could be quicker or will be quicker, but let's just talk about method 1 first. So method 1 involves this idea. So method 1. So method 1 involves you doing this. So let's kind of remind ourselves about this. So method 1 eventually is going to imply this. So method 1. So at some point, you're going to rewrite this numerator and this denominator as one rational expression. So one rational expression divided by another rational expression, let's say 4 ninths. Okay? And then remember, when in the past, in previous courses, when you're dividing fractions, you're going to change this division to multiplication. And to change this to multiplication, you're going to take the rational expression in the numerator, and you're going to multiply it by the reciprocal of the rational expression in the denominator. So the reciprocal of 4 ninths becomes 9 fourths. And then you would reduce if you can. In this case, I can. 2 divided by 2 is 1. 4 divided by 2 is 2. 3 divided by 3 is 1. 9 divided by 3 is 3. And so 1 times 3 is 3. 1 times 2 is 2. And so that's what you would get. You would get 3 halves. Okay, so that's the idea you're going to use in method 1. So let's go ahead and do that. So method 1 is going to involve this. So some of you may want to just cover the denominator up so it doesn't confuse you. So method 1 means you take this numerator, 5, and rewrite 5 as 5 divided by 1 minus 10 divided by x. And you're going to rewrite this. You want to get some rational expression. So 1 fraction divided by 1 fraction. So you want to get to look like this. 1 fraction divided by 1 fraction. Okay? And so that's going to involve you remembering some things that you learned in previous lessons. So you're going to have to rewrite this as one rational expression. So you have to find the LCD. So the LCD of these two denominators is x. So now you're going to write two fractions with x as your denominator. So now we're going to write equivalent fractions. So remember, you want to get this denominator is now 1. You want to get this to be x. So that means you have to multiply 1 by x to get x. But what I do to the denominator, I have to do to the numerator. So x times 5 is 5x. And it kind of makes sense that these two rational expressions are equivalent, because if I divide the x's, if I divide the x's or reduce the x's, I get 5, because 5 over 1 is the same thing as 5. All right, and then over here, the denominators are the same, so that means that the numerators are the same. That means that 10 divided by x is equivalent to itself. And so now, since the denominators are the same, I can write this as one rational expression with the denominator x. And so this becomes 5x minus 10. So notice that this right here is what I want it to be here. Okay? So that means that the numerator then is going to be this one rational expression. So that's going to be 5x minus 10 divided by x. All right? And then you do the same thing with the denominator. So if you look at the denominator now we're going to do the denominator. So the denominator, you have 1 divided by 1 minus 4 divided by x squared. And so the LCD here is x squared. And so now this is going to be, you want to write two equivalent fractions with x squared as the denominator. So 1 times x squared, let me put this, 1 times x squared is x squared, but what I do to the denominator, I do to the numerator. So x squared times 1 is x squared. Kind of makes sense, because x squared divided by x squared is 1. Here the denominators are the same, so that means the numerators have to be the same. So 4 divided by x squared is equivalent to itself. And so this becomes x squared minus 4 divided by x squared. So that one rational expression is going to go here. So x squared minus 4 divided by x squared. And so now you're going to use this idea that we reviewed earlier, that when you have a fraction divided by a fraction, you're going to change the multiplication problem. And notice that this is what I have. One fraction divided by one fraction. So this is going to become 5x minus 10 divided by x times the reciprocal of the fraction that's in the denominator. So the reciprocal of x squared minus 4 divided by x squared is x squared divided by x squared minus 4. Okay, now once you get to that point, the next step is to factor. So remember in a previous lesson when you multiplied rational expressions, you factored first. So in the numerator, I can factor out of 5 to get 5 times x minus 2. This is a monomial. I'm going to leave this as x. This is also a monomial. I'm going to leave this as x squared divided by, and then that's the difference of 2 squares. So I'm going to get x minus 2 times x plus 2. All right, now remember in the previous lesson, or previous lessons, you had to reduce. So what I needed to see, if you don't show this, you're going to lose points. I need to see what you're reducing. So for example, my first factor is a 5. 5 does not occur, or 5 cannot reduce with any factors in the denominator. Remember your factors in the denominator, x minus 2, x plus 2. The next factor is x minus 2. I see an x minus 2 here, so those divide out. This is what you got to show. Now here I have 2 factors of x. I have 1 down here, so I can reduce that. So that becomes 1, a factor of 1, and then I'm left with just 1 factor of x. And that's all you can do. So the answer is going to be 5. We'll do that here. 5 times 1 times x is 5x, and then 1 times x plus 2 is x plus 2. So that's your answer. Okay? All right, so that's the work. So the work you have to show is this right here. This is your work. So if you want all your points, then that's what you have to show. All right, so this is your work. Now you don't have to show this. You can go off to the side and do that part because that's more of the messy part here. Now I want to do number 1 again, but using method 2. I'm going to show you the difference between the two. So remember in method 1, you had to do this, right? You had to write these 2 fractions as one rational expression. In the denominator, you had 2 fractions. You had to write as one rational expression. So let's see the difference between method 1 and method 2. So in method 2, so we're going to do number 1 again. So we had 5 minus 10 divided by x divided by 1 minus 4 divided by x squared. So method 2 involves this idea. So method 2 involves that you look at all your denominators. And so I'm going to go ahead and rewrite this as 5 divided by 1 minus 10 divided by x divided by 1 divided by 1 minus 4 divided by x squared. So I'll look at all those denominators, okay? And you find the least common denominator. So the least common denominator of all these denominators, now remember the denominators have to be factored, but in this case they're all monomial factors. So the LCD is x squared. So once you find the LCD, now here's what you have to do. Both fractions, both terms in the numerator have to be multiplied by x squared, and all the terms in the denominator have to be multiplied by x squared as well. So what you do to the numerator, you do to the denominator. So notice I inserted parentheses here because both of those have to be multiplied by x squared. Same thing here. So now when I distribute, I get 5, this is 5, times x squared, minus, and then this is 10 divided by x times x squared, divided by, okay? And then over in the denominator, I get 1 over 1 times x squared, minus 4 over x squared times x squared. So all I did at this point was just distribute. That's all I did. And now we're going to reduce. So I get 5x squared minus, now remember if I reduce this, x divided by x is 1, and then x squared divided by a factor of x is just a factor of x. And so this becomes 5x squared minus 10x divided by, and over here I get x squared minus, and then these divide out because they're the same factors, x squared minus 4. And now, once you do that, so you see I have one it's kind of like when I did this one, where I had one fraction here. So you see I kind of have now one fraction. So it's not the same as what I had earlier. See, in here, I had rational expression where I had some fractions involved. So now I have a polynomial divided by a polynomial. So now the next step is to factor. So I'm going to factor out a 5x. I get 5x times x minus 2 divided by, and then this is the difference of two squares. So I get x minus 2 times x plus 2. And then all I can divide out here, the x minus 2's, so there's the only factors I can divide out. And so you're left with 5x divided by 1 times x plus 2 is x plus 2. And so notice that's the same answer you had here. All right. So that's the difference between, now this is the answer. This is the answer. So, but that's the work. That's your work for method 2. So let me go ahead and kind of decrease the size so you see a little bit better. All right, so that's your work. Okay? All right, so let's look at number 2. So number 2, let's suppose we had this in number 2. All right, number 2, we have 6 divided by x plus 2 divided by x minus 4 divided by x plus 3 divided by x plus 2 divided by x minus 4. Okay, so let's go ahead and do the two different methods, and let's just see what happens from there. So method 1, remember, method 1 is where you're going to take these two fractions and you're going to write it as one rational expression. So there's going to be method 1. Now remember, that's where you have to go off to the side and kind of do some work, because you got to get this as one rational expression. So we have 6 divided by x plus 2 divided by x minus 4. So the LCD will be, your denominators are factored. So your LCD, this is a monomial, this is a binomial, so it'll be x times x minus 4. So that's your LCD. So now you're going to write two equivalent fractions with that LCD, just like this. All right. Now we're going to write equivalent fractions. So I have an x. I want x times x minus 4. So I'm missing the x minus 4. So I'm going to multiply this by x minus 4. What I do to the denominator, I do to the numerator. So my numerator is going to be 6 times x minus 4. And just go ahead and write it like this for right now. In the denominator, I have x minus 4. So I have this factor. I'm missing this one. So I got to multiply this by x. But what I do to the denominator, I do to the numerator. So the numerator is going to be 2x. 2 times x is x. And then x minus 4 times x is x times x minus 4. Now that I have the denominators the same, now leave them in factored form. Don't multiply the denominators out. What you have to do now is multiply the numerators out, but leave the denominators in factored form. And the reason you're going to multiply the numerators out because you want to be able to combine like terms in the numerators. So if I distribute, I'm going to get 6x minus 24 plus 2x. Divided by x times x minus 4. So notice, leave the denominators factored. Don't multiply it out. Now let's combine like terms. 6x plus 2x is 8x. I get 8x minus 24 divided by x times x minus 4. So that's what I'm going to write in my numerator. So this right here is going to be this. Okay? So that's going to be 8x minus 24 divided by x times x minus 4. All right. Now do the same thing with the denominator. So in the denominator, I have, so I'm going to rewrite this here. So I have x plus 3 divided by x plus 2 divided by x minus 4. And so the LCD will be x times x minus 4. And so I'm going to write two fractions with that denominator, x times x minus 4. X times x minus 4. So now we're going to write equivalent fractions. So x plus 3 divided by x is equivalent to what fraction with this denominator? Well, I'm missing, see, I have the x, I have a factor of x, but I'm missing the x minus 4. So I'm going to have to multiply this by x minus 4, this denominator. But what I do to the denominator, I have to do to the numerator. So my numerator, now you got to be careful here, my numerator becomes x minus 4 times x plus 3. Over here, I have a factor of x minus 4. I'm missing the x. I got to say times x times x. So my numerator will be 2 times x. All right, now remember, you're going to leave your denominators in factored form. It's the numerator you're going to multiply out because you notice you want to be able to combine like terms in the numerators. So you got to be careful here. See how in this case I distributed 6 times x, 6 times a negative 4, and I got 6x minus 24? Because that was a monomial times a binomial, so you use the distributive property. Here, see I have two binomials, so we're going to FOIL this. So this becomes x times x is x squared. The outer is 3x, the inner is a negative 4x, so that becomes a negative x. And then a negative 4 times 3 is a negative 12. And then plus 2x divided by, and then your common denominator, which is x times x minus 4. Combining like terms, I'm going to get x squared. A negative x and a positive 2x is a positive x, and then minus 12 divided by x times x minus 4. So that's going to be, this right here is going to be the denominator. So my denominator is going to be x squared plus x minus 12 divided by x times x minus 4. All right, so now notice these two rational expressions I now wrote as one rational expression, one fraction. So you're adding two fractions, you want to write as one fraction. So there's all the work you have to do to get to that point. Now we're going to change this to a multiplication problem. So I'm going to rewrite this as 8x minus 24 divided by x times x minus 4 times the reciprocal of the denominator. And so the reciprocal of the denominator is x times x minus 4 divided by x squared plus x minus 12. Okay? Now remember we said to leave the denominators in factored form, and the reason is because when you get to this point you want to have everything factored. So leave them in factored. See, those are already factored. Now we got to go back and factor these now. So this numerator I can factor out an 8. So I get 8 times x minus 3 divided by 8 x times x minus 4 times this is already factored. And then over here, when I factor this trinomial, I'm going to get x, let's say it'll be x plus 4 times x minus 3 looks like. Okay? And then now we're going to reduce. So I have a factor of 8. That cannot reduce with any factors in the denominator. Your factors in the denominators are x, x minus 4, x plus 4, x minus 3. The next factor is x minus 3. I see one here, so those divide out. You got to show that you're dividing those out. The next factor is x. It can reduce with this factor of x here, right here. The next one's x minus 4 reduces with this one, just like this. And all you have left then is 8 times 1 times 1 times 1, which is 8, divided by 1 times x plus 4 times 1, which is x plus 4. And so that's your answer. And this is what I want to see. I want to see this right here. Okay? So now keep in mind that you gotta show all this. You have to do all this work. There's no way you'll be able to go from here to here without doing something here. But that's a lot of work, right? So method one in this case is quite it's quite a bit. So let's see what happens if I use method 2. So let's look at method 2. Same problem, method 2. So I have 6 divided by x plus 2 divided by x minus 4. And all that's being divided by x plus 3 divided by x plus 2 divided by x minus 4. Okay, so using method 2, remember method 2 is where you're going to multiply numerators and denominators by the LCD of all the denominators. Okay, so you're going to use the LCD of all the denominators. You got to make sure, though, that your denominators are factored, and there's not anything else you can do with those. So my LCD then will be x times x minus 4. All right, now what I'm going to do now is I'm going to go ahead and rewrite this over. So you got 6 divided by x plus 2 divided by x minus 4 divided by x plus 3 divided by x plus 2 divided by x minus 4. So I'm going to multiply both numerator and denominator. Notice I put parentheses because all these fractions in the numerator and all these fractions in the denominator have to be multiplied by the LCD. Now, the next step is to distribute. Distribute. So here's going to be your step. You're going to say 6 divided by x times my LCD plus this fraction, 2 divided by x minus 4 times the LCD. Okay, just like that. Divided by, and then x plus 3 divided by x times the LCD plus the next fraction, 2 divided by x minus 4 times the LCD. So notice all I did was I multiplied every fraction, 1, 2, 3, 4, by the LCD. So notice 1, 2 is being multiplied by the LCD, 3 is being multiplied by the LCD, 4 is being multiplied by the LCD. At this point is where you're going to reduce. So the x's divide out, and so I get 6 times x minus 4 plus the x minus 4's divide out, so you get 2 times x divided by the x's divide out, so you get x plus 3 times x minus 4. Make sure you put x plus 3 in parentheses, plus, and then the x minus 4's divide out, and you get 2x. Now I want to show you something. So I want you to notice, you see this part here, this part here? That's this part here right here. See that? And you see this part here? That's this right here. So this part is part of this as well. So notice there are some similarities. There are some similarities that you're going to see that's the same here as here. Now be careful. Some students will cross out these two x's thinking that you can. You cannot. So don't cross these out because those are not factors. See, that's a plus sign right here. So that's a plus sign. So you can only reduce factors. 2x is not a factor. 2x is a term of the numerator. Now remember what we did here? We distributed, and that's how we got this right here. So that's your next step. So the next step is to distribute. So in a distribute, I get 6x minus 24 plus 2x divided by, now I got to multiply this out using a FOIL method. X times x is x squared. The outer is a negative 4x. The inner is a positive 3x, so I get negative x. And then 3 times negative 4 is a negative 12, and then plus 2x. Combining like terms, I get 6x plus 2x is 8x minus 24 divided by, and then x squared. A negative x and 2x is a positive x, and then minus 12. Now you see this right here, that is, if I can find it, so that's see this 8x minus 24 and this x squared plus x minus 12? That is this right here, see that? And then this right here. That's what that is, okay? And so now you're going to factor. So you're going to factor out an 8. So you get 8 times x minus 3 divided by, and then when you factor the denominator, you can get x plus 4 times x minus 3. And then these x minus 3's, factors of x minus 3's divide out. So you get 8 divided by x plus 4. And so notice that is your answer. Most students prefer method 2. Most students prefer this method over method 1. All right, so let's look at number 3. And for the rest of the problems, we're going to go ahead and use method 2 because of the time that we have in this video. So number 3. So let's look at number 3. In number 3, let's suppose we have 6 divided by y squared minus 9, and that's divided by 4 divided by y plus 3 plus 1. Okay, so the first thing you have to do, remember we're going to use method 2. So this will be method 2. So method 2 is to find the least common denominator of all your denominators. So in the numerator, I have one fraction, but my denominator is y squared minus 9, so I got to factor this. So let's go ahead and factor this. I'm going to rewrite this as 6 divided by y minus 3 times y plus 3. So remember, in finding the LCD, you got to look at your factors. So you've got to factor this difference of two squares. The denominator, y plus 3, I can't do anything with, so I'm just going to rewrite this as 4 divided by y plus 3, and then plus 1 over 1 if you want to. Or you can just leave it as 1, does not matter. So now we're going to find the LCD. So the LCD of, if you look at your numerator, your factors in the numerator are y minus 3, y plus 3. So I'm going to use those. In the denominator, your factor, if you look at your denominators, the denominators of your denominator, this is y plus 3. I already have it. And then 1 is a factor of all factors. Okay? And so there's your LCD. Now, once you find the LCD, you're going to multiply both numerator and the denominator by the LCD. So I'm going to go ahead and rewrite this over. Y minus 3, y plus 3. So I have one fraction. Now notice though, this is two fractions. So you're going to need parentheses here. Let me show you what I mean by that. So you put that in parentheses, okay? Because both of those have to be multiplied by the LCD. So you're going to say times, so this one fraction times the LCD, and these two fractions times the LCD. Okay? And so now when I multiply this out, so here I can just reduce these. And so this, in the numerator here, I'm going to get 6 times 1, which is 6. Now in the denominator, you got to be careful. So you're going to say 4 divided by y plus 3 times the LCD. So you're distributing this. So times the LCD. So y minus 3, y plus 3. Plus 1 times the LCD. Y minus 3, y plus 3. All right, now, so notice the numerator is just a 6 right here. Just keep in mind that's just a 6. Now, in the denominator, I can factor out the y plus 3's in this part here. So I get 6 divided by 4 times y minus 3 times 1. So I get 4 times y minus 3. Plus, and then do y'all agree that 1 times y minus 3 times y plus 3 is still y minus 3 times y plus 3? Okay. Now the next thing you're going to do is get rid of the parentheses in the denominator. So you can distribute here and you're going to FOIL this out. So I'm going to get 6 divided by 4y minus 12 plus, and if I FOIL this out, y times y is y squared. The outer is 3x, the inner is a negative, I'm sorry, the outer is 3y, the inner is a negative 3y, that's 0. And negative 3 times a positive 3 is a negative 9. Combining like terms, I get 6 divided by, let's put this in descending order. So I'm going to get y squared plus 4y, and then a negative 12 and a negative 9 is a negative 21. Okay? Now let's go ahead and factor the denominator. Now if I factor the denominator, let's see, that's not really not going to help because look, so that's really your answer, because if I factor the denominator, I'm going to get 6 divided by y plus 7, y minus 3. And let me make sure that's correct. Y times y is y squared. The outer is a negative 3y, the inner is a positive 7y, you get 4y, and then 7 times negative 3 is negative 21. And there's nothing ever reduced. So that would be the answer that you would write. Right? But leave it. Now the direction says leave your answer in factor form. This is the one you want. Okay, that's the one because this is the one that's factored. So don't leave it like this. If it says write the answer in factored form, don't leave it like this. This is not factored form. This is. But that is the work for method 2. All right, so make sure you just go over the same problem again. Make sure you follow the steps and try and understand the steps as best you can. Let's do one more. So this would be number 4. And let's suppose in number 4 we had this one. 3 plus 1 divided by x minus 24 divided by x squared divided by 7 plus 22 divided by x plus 3 divided by x squared. All right, so that's number 4. So notice that now remember, we're going to use method 2. Method 2 is usually the more straightforward one. When you do method 1, you have to do some work on the side like this and then bring back this part here. So method 1 kind of confuses the students somewhat. But it is important to know method one because the algebra that's involved here is very important for future topics. So you got to know both methods. Now, in method two, what we're going to do is we're going to find, we have to find the LCD. Now, to find the LCD, you're going to look at all your, let me go ahead and rewrite this. You're going to look at all your denominators. I'm going to write 3 as 3 over 1. Plus 1 over x. X is a monomial factor, so you got to factor your denominators. But in terms of factoring, like I did in the previous problem, when I did number 3, see how in number 3 we could factor y squared minus 9. These are monomial factors, so I'm just going to go ahead and just rewrite these over. I'm going to rewrite 7 as 7 over 1. Some you don't have to. Some of you may want to. It's up to you. You can leave it as just 7. Now remember, the next step though is to find the LCD. So the least common denominator of 1x x squared 1x x squared is x squared. So now what you're going to do is you're going to multiply all these fractions in the numerator and all these fractions in the denominator by the LCD. What you do to the numerator, you do to the denominator. And now we're going to distribute. You're going to distribute. So I get 3 times x squared plus 1 over x times the LCD, x squared, minus 24 over x squared times the LCD. All right, so notice that every fraction was multiplied by x squared. See that? Divided by, do the same thing here, 7 times x squared plus 22 divided by x times x squared plus 3 divided by x squared times x squared. And now let's reduce. So I get 3x squared. Now over here, this x will divide with one of these, so you're left with 1 times x is x. These x squareds divide out, so you're left with a negative 24 times 1 is a negative 24, divided by, this is 7x squared. Again, this x divides with one of these, so you're left with just one factor of x, so that's plus 22x. These factors of x squared divide out, you're left with 3, okay? And so now the next step is to factor. And so when you factor the numerator, I'm going to show you what's going to happen. When you factor the numerator, you're going to get 3x minus 8 times x plus 3. So that's going to be the factors of this trinomial. The factors of your denominator of this trinomial will be 7x plus 1 times x plus 3. And always check. 3x times x is 3x squared. The outer is a positive 9x. The inner is a negative 8x. You get a positive x. Negative 8 times 3 is negative 24. Same thing in the denominator. 7x times x is 7x squared. The outer is a 21x. Inner is a positive 1x. You get 22. And then 1 times 3 is 3. And then now notice the x plus 3's divide out. So your answer is 3x minus 8 divided by 7x plus 1. So that's your method. Now, if you had done method 2, it would have been a little bit more involved because you would have had to go off to the side and do a bunch of work to get to this answer. Okay? All right. Now, let's do one more just to kind of, and we're going to do method 2. So let's do this one. So do we number 5. So we do number 5. And let's say it was this. So 5 divided by x plus 7 plus 10 divided by x plus 5 divided by, and then 3x plus 19 divided by x squared plus 12x plus 35. All right. So the first thing you have to do is, and we're using method 2, so this will be method 2. So the first thing you have to do is to find the least common denominator. Now, to find the least common denominator, you got to make sure all your denominators are factored. So I'm going to circle. I'm going to go ahead and rewrite this over just to show you what I mean. So I'm going to circle the denominators that I'm referring to. So when I say make sure all your denominators are factored, I'm talking about this, this, and this. Okay? So these are linear factors. I can't factor these any further, but I can factor this. So this is going to become 5 divided by x plus 7 plus 10 divided by x plus 5 divided by 3x plus 19 divided by, and then I can factor that as x plus 7 times x plus 5. So this right here is this. Notice that those factors are the same as these. So your LCD will then be x plus 7 times x plus 5. That's your LCD. So now what we're going to do is now remember, it's always a good idea to, your next step is not to use this one, but to use this one when multiplying by the LCD, because these are already factored. So let's rewrite this. So this is going to be, so it'll be 5 divided by x plus 7 plus 10 divided by x plus 5 divided by 3x plus 19 divided by x plus 7 times x plus 5. So now I'm going to multiply both numerator and denominator by the LCD. So the whole point is to get these fractions to be factors of 1. Now notice though that in the numerator I have two fractions, but put that in parentheses. I'm going to say times the LCD, x plus 7, x plus 5. The denominator is just one fraction, so I'm not going to put that in parentheses. I'm just going to say times x plus 7, x plus 5. And the reason is because right now I can see that those divide out. So the x plus 7s divide out, the x plus 5s divide out. Over here, though, I've got to distribute. And so this becomes this fraction times the LCD, just like this, plus this fraction times the LCD, okay, divided by, and then all you're left with in the denominator is just 3x plus 19. And so now in the numerator, let's go ahead and reduce. So these x plus 7s divide out in the numerator. So I get 5 times x plus 5. Okay. Over here, the x plus 5s divide out. So I get 10 times x plus 7, just like this. So 5 times x plus 5 plus 10 times x plus 7. The denominator is just 3x plus 19. And so now distributing here, let's see what we get. We get 5x plus 25 plus 10x plus 70. 10 times x, 10 times 7. Divided by 3x plus 19. And so 5x plus 10x is 15x. 25 plus 70 is 95, right? Divided by 3x plus 19. And then now notice in the numerator, I can factor out a 5. So I'm going to get 5 times 3x, and then 95 divided by 5 will give me, so 95 divided by 5 will give me 19, just like this. The denominator is also 3x plus 19, right? So these 3x plus 19s divide out, and your answer is just 5. So that is your work. So it looks complicated, but the algebra skills are very important. So make sure you go through this process and understand everything that we did. All right, so don't just look at the written part here. Make sure you go back and listen to the words as to how we got this written part. Okay? All right, so that's going to be the end of this lesson.